Star Talk, an explainer. We do this sometimes. Chuck.
Hey.
I need you there when we do explainers. But this one, I know a little bit about. We're going to talk about the James Webb Space Telescope. I know a little bit about it, but not enough to fill a whole explainer on it. Mm-hmm. So we reached in to NASA headquarters, and we found the chief scientist. And there he was, and he's on Star Talk right here, right now. Jim Green. Jim, it's a delight to have you. We go way back. Thanks for being on Star Talk.
Neil, my great pleasure. And Chuck, good to see you again.
Definitely good to see you, Jim.
Jim Green, you come to us as a planetary scientist from way back. And you're chief scientist at NASA, and you're retiring next year. Where will we go? What will we do? What are we going to do? Oh, my God. And wait, you're retiring right when the James Webb Space Telescope deploys. This is a little suspicious, if you ask me.
Not really, but after 42 years, it's time, to step into retirement. But, I'd like to continue to work with NASA. I have several papers I need to finish. Nice. I want to work with NASA on gravity assist and, do these things that I like to do.
So you've got a gravity assist podcast. That's the best title ever for a podcast. I just want to put in my vote for that. And you just published a book, a 50-year review of planetary exploration at NASA. And it just came out. Just congratulations on all of the above. The podcast, the book, the retirement, the career. And now we got to pick your brain about James Webb Space Telescope. Yeah, and I got 100 questions, and I just want to hear it from the horse's mouth. Sorry to call you a horse in this, but...
a mouth I do have.
All right, everyone is thinking of this as like the replacement for Hubble. So could you just amend that thought for us all?
Yeah. When we go into space, we have the wonderful opportunity to look in different wavelengths of light that don't make it to the surface of the Earth. Now, Hubble actually looked at the visible. Many of those wavelengths, all those wavelengths make it to the surface of the Earth, but not into the infrared. And that's why we needed a new telescope. And that's what the James Webb Space Telescope does. It really hones in on a brand new wavelength regime that we haven't done much with.
Wow. So what intrigues me is when I first learned of the James Webb and how it's tuned for the infrared, I being fundamentally a large-scale structure guy of the universe, I was very excited to recognize that it will be able to see the formation of galaxies in the early universe in a band of light that is redshifted into its zone. I mean, it's like the universe is it's like
time
universe.
Machine.
Put it here, universe, and then we got you, right?
Wow.
Right?
Yeah. Well, it's a time machine.
Yeah, so basically,
The further it looks, the further those objects are away, the further back in time we see them.
And their light was started out as ultraviolet or maybe even some X-rays. And by the time it reaches us through the expanding universe, it's landing in our lap as infrared, and you got the damn telescope to find that.
Yeah,
but then to learn that it's not only finding the farthest reaches of the universe, infrared can actually peer into gas clouds. So tell us about that.
Well, that's a really important aspect of it because it allows us to look at the birth of stars and their associated planets. And that really is exciting to see.
And these are just right in front of our noses, right? So that's what intrigues me. It's the farthest reaches of the universe and things that are happening right in our backyard, our cosmic backyard, right? Within our own galaxy.
Where do you decide to point it first?
Ooh, good question.
Oh, well, scientists propose.
Right, there's a cage match. There's the octagon, and we go
with the chainsaws. Don't forget the chainsaws. You got to have that.
Jim, you got to put that in. That's got to be your retirement legacy. The first light on a telescope is whoever wins the cage match among the astronomers. You got to do that.
Yeah, right. Indeed. Well, much of that early part of the program's been worked out. But we also have some time, about 100 hours that have been set aside to look at the solar system. Now, this is really an exciting thing because I was at NASA headquarters as head of planetary science from 2006 on. And in about 2007, we went through a review on what JWST could do. And in that review, I said at the end of it, well, aren't we going to use it to look at objects in the solar system? Because our sun heats them up and they glow in the infrared. And we can look at infrared aurora on planets. All kinds of things were coming to my mind. And I was told, no, this is an astronomy telescope and we can't track things. And so Alan Stern, the AA at the head at the time, turned to me and said,
Pluto. He's Mr. Pluto.
Mr. Pluto.
It's Alan Pluto Stern. That's his middle name.
Wow.
We've confirmed that.
Your mortal enemy.
No, stop. don't get anything started. Don't derail this conversation, Chuck.
So Alan turned to me and said, well, what do you think we ought to do about it? I said, let's take a second and see if what needs to happen for JWST to track objects in the solar system. And so it was early enough in the development, the project went away and they came back a couple months later and said, we got great news. It's just a software set of mods that we can make and we can track things from Mars on out.
Wow. So there's an important point you're making there because when we see the distant universe, nothing is moving at any rate that matters to, you just sit on that spot in the sky. But everything in the solar system is moving.
Yeah. And of course, we need time to collect those photons, even though we have a huge collecting area. We want to see out into the Kuiper belt, and they'll emit infrared, but they're so far away from the sun that it will still be dim.
The Kuiper belt, of which Pluto is a prominent member.
Yes, one of the archetype members of.
Or you mean escapee?
Oh, I don't know. It's true.
Oh dear. Oh, what have I done?
Well, some of them haven't escaped. You got Triton, which is probably a Kuiper belt object, in orbit around Neptune. So what happened is the project said it just costs money. Now's the perfect time to do it. Add the money, and we can complete the software and track objects. And Alan turned to me and said, "Green, you got the money?" And I said, "I'm going to do whatever I can to get you the money." And indeed, that's Planetary's investment in this spectacular telescope is getting the software that enables the telescope to track objects from Mars on out in the solar system.
That's a beautiful thing. And remind us where this thing is getting planted. It's not just in Earth orbit like Hubble.
That's right. It's in a very special place. And this particular place is behind the Earth in what we would call the Earth's magnetotail, okay? Whoa. And it's called L2. It's
That's a new anatomical part,
Yeah, yes.
That's right.
Magnetotail.
The magnetotail.
It sounds like a new X-Man.
Magnetotail. That's right.
So that's how you remember to pronounce magnetosphere correctly is think of magneto and then put a sphere on the end of it.
Good. There you go.
Nice.
All right, so this is on the other side of the moon, right?
No, it's directly behind the Earth in line from the Earth to the sun.
Oh.
Interesting.
L2 is behind us. And it's a unique place because what's happening is in that location, it's really orbiting the sun. But because it's behind the Earth, it would move slower around the sun than the Earth does. But here's where the Earth comes in. The gravity from the Earth pulls it along. And so not only the sun's gravity, but the Earth's gravity keeps it in a nice position we call L2, which is like 920 million miles away from the Earth.
So this has nothing to do with the moon. The moon keeps doing its orbit around the Earth like nothing's happening while this spacecraft is still out there. So if you're in L2, can we get there to service it in case we need to?
I know that's a big topic. A lot of people ask that, and the answer is it never was planned to be serviced.
So?
So we're not going to be able to do that at this stage.
At this stage. Okay. So in principle, though, L2, if it's going to be a happening place to plunk future space telescopes and whatever else might live there, because Lagrangian points, those are fun points to hang out in. I can imagine, I'm making this up, just spitballing here. NASA has a has a handyman mission. It's the handyman vehicle that goes out there, and you collect all the spacecraft that need all the space telescopes that need repair, and then it comes back. How about that?
Well, that's a good thought, but that's not NASA's thought. Our prime mission is indeed for a nominal 5-year mission, but it has fuel to station keep, meaning stay in L2, for about 10 years.
Wow.
Yeah, I'm thinking of a handyman mission. Okay,
Yeah.
I'll work on that, Jim.
We'll call it NASA's AAA.
AAA comes. Oh, you got a flat. You need a jump.
Well, you may need fuel. That's probably what you'll need.
I can't believe I locked myself out of my satellite. Ah.
Wait. So Jim, I got one last question because we're running short on time. Is there a mode the telescope can go in that is, because what I always loved, even telling the public about that we do as scientists, is, of course, you design an instrument for what you intend to find. All right, that's how you know what the parameters are and what the specs should be. But is there a mode where it's just looking for nothing, like a serendipity mode? So in case something shows up that nobody ordered, nobody was looking for, and we end up scratching our head when it shows up.
Like every other telescope in New York City.
Well, like Hubble, which decided, okay, we've got some spare time, let's just stare in an area, and then found the fabulous array of galaxies that it did. There'll probably be some time when we will look in a particular area and then just turn it on and see what we find. But at the moment, it's really well subscribed, as we would say. We have 100 hours open to the planetary scientists to make a variety of measurements of solar system objects. That data will come in and be available to all the other planetary scientists. And then many of the astronomers will have already accepted proposals, and they'll be following that schedule that they've created. But that won't really kick in until 6 months after launch.
Okay. But the point with that famous photo, the Hubble Deep Field, where it just stared at nothing for a long time. It became one of the most famous images it ever took. That was the director of the Hubble Space Telescope Institute saying, do this, and I don't care what anyone says, because I'm the director, and I have director's discretion every time. Is there someone in JWST, because it's not going to be you because you're retiring, is there somebody who's going to say, let's just do this, don't judge me until after? Is there someone who has that power?
Perhaps. Another
cage match.
But Hubble was up for many, many years before that. All right, and therefore they felt they had an opportunity to then reach outside the normal set of things that they'd be doing to discover something new and important, perhaps. Man, did they ever.
Very good point.
And so that's why I say initially it's really well subscribed. We've got so many things we know we need to make those observations, to make those discoveries, and so that's first on the list.
All right, Jim, It's been great to have you on here. We've got to end it there, but we look forward to the launch. We look forward to the successful deployment. That's going to be a nail-biter, deploying something that's never existed before.
Right.
Who knows if somebody forgot to, unlatch something before it was loaded.
Right.
Then someone needs some explaining to do on that. But anyhow, we look forward to this, and congratulations on a marvelous career. I've known you ever since I've known NASA, so I feel like you and NASA have become one.
Well, thank you. That was very kind of you to say.
And your Gravity Assist podcast, check it out. And of course, 50 years of planetary exploration, just published by NASA. And so you can check that out as well if you want.